All right, guys, today we're going to go back to 2 dimensions, and then in 7.5 we're going to put this all together again. But for 7.4 we're going to just find arc length, which is the same as the length of a curve. We're going to try to figure out the exact length of a curve. So let's just take a look. Let's say we have this curve, okay, and we're going from A to B, okay. It's a simple idea that we're going to break it down into a whole bunch of little right triangles. Okay, and the smaller and smaller each of these right triangles gets, right, and we're going to do a whole bunch of them. The smaller and smaller each of those right triangles get, the hypotenuse and the curve will become one. I mean, even here, you can kind of see that they're pretty darn close, but as each of these gets smaller and smaller, the curve and the hypotenuse will become the same thing. Now remember, we're going really, really small. What's that idea of making things really, really small and then adding them all together? Well, the idea of making things really smaller and smaller and smaller, right, and then adding them together, that's integrals. So this, let's take a look at one of these triangles. Okay, we're going to take a look at one of those triangles. This distance is the change in x. So we're going to call this dx. And this is the change in y, going up and down. So this is going to be dy, and then that'll give us our hypotenuse, which eventually the triangle and the curve will become the same. So this, our Pythagorean theorem, right, says dx squared plus dy squared will equal c squared. Equals c squared, right? A squared plus b squared equals c squared. All right, so we just want c. So what are we going to do? We're going to take the square root. Okay. So the square root of dx squared plus dy squared equals c. And the idea is we want more and more of these right triangles, and we want to add them all up. And so that is the integral. The integral from A to B. And we want to add up all these square roots. Dx squared plus dy squared. Okay. So now that doesn't look that great, right? We got x's, we got y's. We don't have a dx all by itself out here, and so that's what we're going to do. We're just rearranging this so that we can get an equation that we use. And the trick is, what do we do next? We're going to factor out. We're going to factor out a dx squared. Okay. Now, one way to kind of see what's happening when you factor something out is to divide. So we're going to divide by dx squared. Okay, so if we divide by dx squared, let's see what we have here. We've got, when I factor it out, I have to put it out there though as well. So I factored out a dx squared. Okay, so now what am I left with? I'm left with, well, this goes to 1, and this would be dy over dx, and then squared. These two go together like that. Okay, that looks good. Because this dx squared divided by dx squared, that's going to take me to 1. Okay, and then this we're just going to write as dy over dx. However, this should ring a bell. Dy over dx, that's the derivative. That's the derivative. And this, now that I'm multiplying, up here these cannot cancel because I'm adding. But now that I'm multiplying, these two do cancel, and I get a dx all by itself. So now we got the integral from A to B, and then we've got the square root of 1, because this is going to go to dx. This guy here, the square and the square root are going to cancel, and so I have a dx out here. Okay, so those two go together. Okay, and then this 1 goes here. And this, I mean, I could write it like this, but dy over dx, that's the same as the derivative of y squared. Okay. Now that looks a little weird because we've got the y, but the derivative of y is going to be in terms of x. So that's it. That's going to find us arc length. And if we wanted to, instead of factoring out a dx, I could have factored out a dy, and that would have put everything in terms of y. So let's write or. If I want to do it in terms of y, we'd have to go low to high. Okay, so low to high would be c to d. And then it would actually look like 1 plus the derivative, but you'd have to solve for x, so that would be in terms of y, and then dy. Make sure you can see just enough. Let me sneak it up. Okay, so that is going to find us. What is that going to find us? That's going to find us arc length. Okay. All right, so let's try some. That's it. That's going to be our formula. All right, so directions. Guess what the directions are? Find the arc length. Find the arc length of the curve. Okay, and so y equals 1 plus 6x to the 3/2. That's my graph. Okay, I'm going to find the arc length, and they have to tell us this. They want us to find it from 0 to 1. Okay, so that has to be given. They have to give us the equation, and they have to tell us where they want us to find it to. Okay. So now I went ahead and graphed it just so you want to see a picture of that graph, and it does look pretty close to a straight line, but keep in mind it doesn't have to be a straight line. We're going to find this curve. I went ahead and only went from -5 to 5 just to spread it out just a little bit. And then we're just going to find from 0 to 1. We're going to find where it actually maybe curves the most, so to speak, but we're going to find this exact length. So if we took a piece of string and curved it and then pulled it straight, that's where we're going to find that exact length. Okay. All right, so let's go at it. We know that we're doing it in terms of x, so we know automatically that we're going from 0 to 1, and it's going to be the square root of 1 plus, we got to do the derivative of y and square it. Derivative of y and square it, and then that'll all be in terms of x. Okay. All right, so let's go find the derivative. Let's go find the derivative of y. Should I rewrite y first? Well, that's okay. We'll just do it down here. Derivative of 1. We haven't done derivatives for a long time. Who's ready for derivatives? So derivative of 1 goes away. The derivative of this guy, roll it down, subtract 1. So roll it down gives us 6 over 1 times 3/2, and then subtract 1, which would take us to 1/2. Okay. And so then that takes us to what? Derivative, that takes us to 9x to the 1/2. Okay. And then remember, this is my derivative, and then I also have to square it. So the derivative squared. So what is that going to look like if we square it? All right, so the derivative of y squared is exactly what I need. Because I'm multiplying, it is okay to bring that in. So 9 squared gives us 81. And this is kind of nice, right? When this comes in, you multiply. So that'll just give you x. All right, so this goes in there. Okay, so let's take a look at what we have. We got the integral from 0 to 1, the square root of 1 plus, what's going to go in here? We not only took the derivative, but we already squared it. So that would be 81x and then dx. Okay, and so now we just have to go at it. How do we take this integral? Now this is a little bit harder because we have that square root. So we're going to have to take a little bit of time. We're going to have to probably use a lot of u substitution. So we got to get this a quantity. So now we got to go off to the side. U equals 1 plus 81x. Okay, du equals, that one goes away. That becomes 81 dx. So we have to divide both sides by 81. Okay. So 1 over 81 du, all that is going in, not that it's that much, but all that is going in for dx. Okay. So now we got the integral from 0 to 1. This whole thing, though, is now u. So So we got the square root of u, and then what's going in for dx? 1 over 81 du. Okay, so that went in for that, and that whole thing got replaced. Good. All right, one more step, and then we'll take the integral. We can move the 1 over, how are we doing on space here? 1 over 81, we can do that if we want. I'm going to write this as u to the 1/2. Okay, and so now we're good. Now we're going to add 1. Now, after all that, we can take the integral, add 1, divide by the new. So add 1 takes us to 3/2. Divide by 3/2 is the same as multiplying by 2/3. Okay, so divide by the new, multiply by the reciprocal. Now, just be careful here. Remember, if we're in terms of u, we're no longer going from 1 to 0 because these are x values. So you have to take it and plug it in here to change it from an x to a u. So I'm going to do 1 plus 81 times 1. This 1 and this one are the same thing, right? I took that 1 and plugged it in for x. Okay, this might show up a little bit better. 1 plus 81 and then 0. I take that 0, plug it in for x. Okay. All right, so we got just a few more steps. So that is going to give us what? It gives us 2 over 243, and then u to the 3/2. Let's clean this up. So this is 82, and then this is 0. So that actually, ironically, that then is that right? That then goes to 1. Yeah, okay, we're okay. All right, so, okay, then our answer is, I'm running out of room here. Let's slide this up. Usually what we do is we can, it doesn't matter. A lot of times we leave the 242 divided by 243, we leave that outside, we like factor it out, and then it would be 82 to the 3/2, and then we would just plug in the 1 minus 1 to the 3/2. Okay. And then this, 1 to any power, so 2 over 243, 82 to the 3/2 minus 1. Okay. Just like that. Crazy answer, but that is the exact length of the curve. If we type that into our calculator, got a decimal, that would be the exact length of, let me see if I can turn it back on, of this curve, strictly from 0 to 1. Okay. All right, let's try another one. There. This one's almost the same. It just starts out weird. I don't know exactly why our book did that, but it starts out y squared equals 4x plus 4 to the 3rd. Okay, we're going from 0 to 2, and then because of this whole squared thing, they have to tell us that they want y is greater than 0, which is pretty normal, right? But that's kind of just making sure that we're getting into that first quadrant. So really the first thing we have to do, well, we know we're going in terms of x, but we have to clean this up, right? Even to graph it, we have to figure out what's going on. So the very first thing we're going to do, I'm not exactly sure why they wrote it like that, but we have to, I guess technically if they want to include both the positive and the negative, but here they're making us just do the positive anyways. But so we're going to take the square root. Let's take the square root of both sides. All right, so that original graph and y equals, now because we're multiplying, we can do it in pieces. So the square root of 4 is 2, and then I'm going to write this as x plus 4, and then the square root, I'm going to do 3/2. All right, so I literally took the square root of 4, and then the square root on this parenthesis, I'm just going to write it, since there's a exponent anyways, and we need exponents, to do derivatives, I'm going to put it over 2. Okay, so now we got these two things. Technically, when I take the square root, I have to do plus or minus. This is telling me just to do the positive. Okay. All right, so I could even write it over here because I know I'm going to do 0 to 2. I know that I'm going to do 1 plus the derivative of y and square it, and that's going to all be in terms of dx. Okay. So this is what I need. I got to find the derivative, and I have to square it. So let's go at it. Let's find the derivative here. Derivative is, the coefficient stays, so I'm just going to roll this down. So 2 times 3/2. Roll it down, subtract 1. So that takes me to 1/2. 3/2 minus 1. And then don't forget, technically I have to do the derivative of the quantity, the chain rule. But the derivative inside here is just 1. If you want to write it, you can, but just to remind yourself, most of the time they give us some pretty nice things, but don't forget, technically we have to take that derivative. All right, so what do we get? Derivative, that cancels nicely, so we get 3x plus 4 to the 1/2. Okay, that's the derivative, and then we have to square it. Okay, so we get 3x plus 4 to the 1/2, and then square it. All right, so what does the derivative squared look like? Same thing, because I'm multiplying, it is okay to bring it in. So 3 squared takes us to 9, and these we get to multiply, which just takes us to 1. So we have x plus 4. Okay, so now the number one thing, don't forget, after all this work, don't forget this 1 here. So now we've got the integral. We know we're going from 0 to 2, but we have the square, and don't forget the square root. We've got 1 plus, and then this is the derivative and already squared, so that's good. What else could we probably have done there? If we could have done it up here, we can do it here. We're going to have to distribute. 2 square root of 1 plus 9x plus 36. Okay. So we've got 0 to 2 square root of 9x plus 37 dx. Okay. All right. So now it's just a matter of taking this integral. Again, we have to do u substitution. So u equals 9x plus 37. du is equal to just 9, right? The derivative of this guy's 9. This one goes away, so dx. Divide both sides by 9. 1/9 du is going in for dx. Okay. So we got the integral 0 to 2. This whole thing, though, becomes u. So I'm going to write this as u to the 1/2. I'll change that to a 1/2, as well as change that whole thing to u. And then this becomes 1/9 du. If I want to pull the 1/9 out, I can. Otherwise, yeah, maybe I will. 1/9, 0 to 2, u to the 1/2 du. Okay, so that looks good now. Okay, actually, that would be maybe a good time to change it over, but we're still going to need this guy, right? This guy is going to come into play just a little bit. All right, so let me slide it up though. Let's actually take the integral, right? So now we're ready to go. Add 1, divide by the new. So add 1 takes us to 3/2. Divide by the new is the same as multiplying by the reciprocal. Okay, so that gives us 2 over 27. U to the 3/2. Now, just be careful. I'm no longer going from 0 to 2. I have a u in there, so I have to take a 2 and plug it in here. I've got to do 9 times 2 plus 37. And then I've got to do 9 times 0 plus 37. Okay. All right. So that, maybe I'll write it over here. So that is what? 2 over, make sure you can see it, 2 over 27. U to the 3/2, and that should be 55 and 37. Let's see, 18. Okay, yeah, just want to make sure. Okay. All right. So that, let me recopy that guy. Make sure you guys can see. Okay, so that I'm just going to recopy 2 over 27. U, what did I have to the 3/2? 55 and 37. Okay, good. All right, so now we can pull the 2 over 27, we can pull that out, and then we can just do 55 to the 3/2 and 37 to the 3/2. That one is not even as pretty as the other one. That one's even messier, but that's it. That's my answer. That's the exact area, or yeah, that's the exact length. That is the exact length of, if I graphed, I could probably graph this guy and go from 0 to 2. Okay. Good. Okay, let's try another one. Okay, let's do a few more. All right, this one gets a little dicey. And the main thing is we have to remember a plus b squared, okay? A plus b squared is equal to a squared plus 2ab plus b squared. So we're going to have this, okay, which gets it's not going to be as nice as we're going to have fractions in there, so it's going to be a little crazy. But we're going to have this, which means it factors to this, okay? But it's going to be a little bit harder to see this, so I'm going to kind of give you a heads up that it's like this. Okay, so let's try this one. X equals y to the 5th over 6 plus 1 over 10y to the 3rd, and then we're going between 1 and 2. Okay, so this is going to be this would be a little bit harder to graph, but it was nice that they gave us it to us as x equals. But to graph this would be a little bit harder. And then we're going from 1 to 2, but notice it's a y value. So whatever that graph looks like, we're going from 1 to 2 this way. Okay, so this guy's really important. We got to identify this, and it kind of gives it away by them giving it to us as x equals. So this means we're going to be going from c to d, which is still 1 to 2, and then it's going to be the square root of 1 plus, and it's the derivative of x, and then squared. Everything is going to be in terms of y, and that's okay. That's the other version of the equation. Okay. So that's it. That's ready to go. So we need to take this derivative and then square it and take a look and see what we have. So let's even rewrite this. I'm going to rewrite this as 16y to the 5th. Okay, 16y to the 5th plus, how can we rewrite this? This is going to be 1/10 and then y to the -3. All right, so let's take its derivative, roll it down, subtract 1, so that gives us 5/6y to the 4th, and then this gives us -3/10 y to the -4. Okay. But now when I have to square that, what do I have to do? I have to write that out twice and FOIL it. Maybe to save a little bit of, well, we could do it here. If we square it like that, all right, if I'm going to square that quantity, then I have to write it out twice and FOIL. Okay, so let's write it out twice. 5/6 y to the 4th minus 3/10 y to the -4. Let's write it out twice and FOIL. Okay, so what does that give us? First gives us 25 over 36 y to the 8th. Okay, this will give us what? This gives us what? -15 over 60, which is 1/4. But what happens when I multiply the y's? I add the exponents, and it goes away, right? The y's go away, -4 or 4 and -4. Same thing here. This gives me another -15 over 16, or -15 over 60, which is 1/4 negative, because this guy's negative, and then these guys go to 0. So another -1/4. Okay, and then last gives us 9 over 100. Y to the add those exponents, so -8. Okay, so let's clean that. So we get to clean this up a little. We get 25 over 36 y to the 8th. This would give us what? -1/2, and then 9 over 100 y to the -8th. Okay, so that goes in right here. Okay. I still have this 1 plus, and I still have the square root. Okay, so let's rewrite. Oh, let's see. Make sure that before I leave, make sure that you can see that bottom line there. Okay, that is the derivative of x squared. Okay, so let's plug it in here. What is that going to look like? All we've got, all right, so we've got the integral from, what was it, from 1 to 2. Okay, we've got the square root of 1 plus, and now we put in this value that we just found, 25 over 36 y to the 8th minus 1/2 plus 9 over 100 y to the negative 8. Okay, dy. Okay, so now we actually have 4 terms. So out of these 4 terms, and this makes a big difference, this 1 and this minus 1/2 go together, and so now we can make it positive 1/2. So now we got the integral from 1 to 2. We got this guy here, 25 over 36 y to the 8th. This is now going to be plus 1/2, and then 9 over 100 y to the negative 8. Okay, and this, this trinomial correlates to this guy. That trinomial, this is a squared, this is b squared, and if you did 2 times a times b, you would get 1/2. So if this is a squared, what is a? Let's write it like this, because we're going to change this to this guy. So we need to know what a and b are. So let's rewrite this. So this is going to be what? 5 over 6 y to the 4th, and then squared. Okay. And then this 1/2 is like 2ab. Okay, so if you put this here for a, and let's write what b is. B would then be what? 3 over 10 y to the negative 4 squared. If you put that there for b, not the squareds, but just those values, because remember, this is now a and this is now b. Okay. You would actually then get your 1/2. Okay. So that means that this factors to a plus b squared. We still have the square root. We're still going from 1 to 2 dy. Okay. This one is just a little bit harder. But now we're in good shape. Now we're in good shape because now we were able to combine that 1 plus, and so now we just have this one thing, and so now these two cancel each other out. Those cancel each other out, and so now we've got 1 to 2, we've got 5, 6 y to the 4th, and 3/10 y to the negative 4th dy. All right, and so now we can take the integral. So now add 1, divide by the new. So we've got 5, 6. We can multiply by 1/5, y to the 5th. Okay, just be careful here, because when you add 1, you get what? A negative 3. So we're going to do negative 3/10, like that. And then we're going from that, we actually took the integral, so we're in good shape. We're going from 1 to 2. We don't have to do any u substitution, so that's kind of nice. Let's clean this up a little bit. We got 1/6 y to the 5th, and here the 3's cancel, so we got minus 1/10 y to the negative 3, and then we're going from 1 to 2. Okay. Now, just as a matter of plugging it in, the answer still doesn't turn out to be that great, but we've got 2 to the 5th over 6 minus, so 2 to the negative 3 over 8. Okay, and then just be careful, minus, it would be what, 1/6, because you plug in a 1, you go to the 5th. Plugging in a 1 there would still keep it 1, so minus 1/10. Okay. This guy makes it a little messy, so it actually turns out to be 1,261 over 240. Good. Okay, so what is that number? That's the length of the curve from 1 to 2. Okay, the length of the curve from 1 to 2. All right, let's try, see if we can get through 2 more. If we can get through 2 more, we'll be good. And this was the longest one, this is the tricky part right here. All right, let's take a look at y equals ln of cosine of x, and we're going from 0 to pi over 4. All right, so we want, let's set this up. We're going to go from 0. Now we're back to in terms of x, which is nice. We're back to in terms of x, so we're going from 0 to pi over 4. So we want the square root of 1 plus, take the derivative and square it, dy. Oh, geez, what am I saying? Not dy, dx. We're back in terms of x. I think writing this y throws you off a little bit, but remember the derivative of y has x's in it. So we're back to in terms of x. Okay. All right, so let's find the derivative. What's the derivative there? What's the derivative of ln? The derivative of ln is what? 1 over cosine of x, but then chain rule says we have to take it times the derivative of cosine. Derivative of cosine is negative sine. So that means the derivative is negative sine over cosine, which means that the derivative is negative tangent. Okay. And then don't forget we have to square it. So there's not much we can do on this side except the negative goes away, and so we can write the derivative squared is equal to tangent squared. All right, so that goes in for that guy. Let's go 0 to pi over 4. Square root of 1 plus tangent squared dx. This is a trig identity. This is a trig identity. 1 plus tangent squared is a beautiful secant squared. Why is that so beautiful? Because I've got the square root, right? So I got the square root, secant squared, right? Those cancel out nicely. Now, it looked good for a minute. We do not know how to take the integral of secant. So that was just one of those I ended up looking up then in the chart because we never covered that. So I will tell you, and I believe secant pops up on your homework as well. So the integral of secant, I'm telling you what this is. The integral of secant is the natural log of the absolute value of secant plus tangent. Okay. So you'll have to use that on your homework as well. You should be okay. And that, I took the integral. That is the integral. So we're going from 0 to pi over 4. Okay. All right, let's just finish it off. Let me rewrite that again. So again, let me rewrite the integral. What is the integral of secant? The integral of secant is ln secant plus tangent. Okay. And then we're going from 0 to pi over 4. Okay. So now it's just a matter of plugging that in. ln, let's see, secant, so secant of pi over 4 plus tangent of pi over 4, and then minus ln secant of 0 plus tangent of 0. Okay. All right, so pi over 4 puts me here. Remember, it's square root of 2 over 2, square root of 2 over 2. So secant is the reciprocal of cosine. Secant is the reciprocal of cosine. So I've got ln. Secant of pi over 4 then is 2 over the square root of 2. Okay, tangent is y over x. So tangent then is 1. Okay. And then ln 0 is here, right? And the point here is what? 1, 0. So secant is technically the reciprocal of cosine, but that's still going to be 1. And tangent is y over x, 0 over 1. 0 over 1 is still 0. Okay. We can even do this side, so let's do this. So that gives us ln of 1. I don't know why I changed it from print to cursive, but and anything to the 0 power gives us an answer of 1. So ln of 1, so this is 0, so that goes away. And so this is basically our answer. ln, we don't need the absolute value. So we could just do parentheses, square root of 2 plus 1. Sometimes, I mean, that answer is okay. Just take a look. What happens? I should have left more room. What happens if we rationalize? Let me rewrite this. We still have the plus 1. But if I rationalize this, okay, if I rationalize this, I get 2 square roots of 2 over square root of 2 times square root of 2 is 2. And so that actually cancels. And so just a nicer answer, just a different version of this one that looks a little bit nicer if you rationalize, ln square root of 2 plus 1. Okay. Good. All right, we're on a roll. Let's do one more and then we're done. Let's do one more. Let's do this one, guys. Come on, we got to do cosh and sinh, right? It wouldn't be math if we didn't do that. All right, so y equals 3 plus 1/2 cosh of 2x, and we're going from 0 to 2. Okay. All right, so everything's in terms of x, so we need this guy's derivative, and we need to square it. Remember, we're going to go 0 to 2, square root of 1 plus the derivative of y squared, and it's going to be in terms of x, because y will be in terms of x. Okay, so let's find the derivative. That guy goes away. That stays, right? 1/2 stays. Derivative of cosh is sinh. But don't forget you have to take the derivative of this quantity, so times 2. All right? So the derivative isn't too bad. What is the derivative? Because those two would cancel, and so the derivative then is sinh of 2x. All right? And then squared, we're just going to literally square that. So this, I think we can go right in. 0 to 2, the square root of 1 plus, this would be sinh squared 2x. Okay. All right, so now don't forget cosh minus sinh equals 1. So if I add a sinh to this side, what do I get? Cosh squared equals 1 plus sinh squared. And so this whole thing could get replaced, just I have a 2x there, and so that's okay. So this is going to be the square root of cosh squared of 2x, which is beautiful. Now those cancel. So I have the integral from 0 to 2. Those cancel of cosh 2x dx. Okay. I just have to be careful. I am going to take the integral of cosh, which is sinh, but I do technically have a quantity. So I do have to go off to the side. U does have to be 2x. Du then is going to be 2 dx. Divide both sides by 2. So 1/2 du replaces dx. Okay. So I do have to do cosh of u, and then this is going to be 1/2 du. Okay, so now I'm good though. Integral now of cosh is officially sinh. I can either I can put the 1/2, well, we could write u 1/2 du. Okay, and we're going from, now be careful, we're either going from 0 to 2, or I can plug like the 2 back in. So maybe I'll write, in this case, in that other one, I changed the u. It all depends how you want to do it. So I'm going to write 1/2 sinh, and then I'll just replace this back, 2x, and now I can go from 0 to 2. Okay. All right, so we plug in 1/2, how am I doing? Oh, we can't see. 1/2 sinh 4 minus 1/2 sinh of 0. This one we might not know. This one, sinh of 0, remember it deals with the hyperbola. 0 means there's no area. Remember, this 0 doesn't really mean angle measure. It means that there's no area. And the only point we know for sure is this point right here, which is 1, 0. So sinh is 0. So this whole thing goes to 0. And so make sure you can see 1/2 inch of 4, that is the length. Okay, good job, guys. All right, so head to your homework, see how you do.